Hello, we are from Group 1. We're doing a master cylinder servicing. First, we are going to open the screw. Strong. Then separate the reservoir and the piston. Remove the rubber. Okay.
Use a long nose to remove the O-ring. Sampai begin, relax. Oh, strong bro. Nice piston. Hadi tu. Oh, strong. Very strong ah. Tak ada ketinggalan. Piston is rusty. To the spring. Akan sini kan? Pas. Ke biar je dengan bekas. Yang ni kena welding ni. Baru tak. Jadi welding, kelas. Drill tu. Buka ni spring tu pun. Oh, brake fluid. Yang. Damn. Ini ada brake fluid tu. Hah? Kita dah salah. Kita dah buka ni. Dia buka. Ada minyak. Apa yang nak buka? Dia buka. Tengok ni. Dia buka ni. Oh, tak apa. Ni brake dia ni tak yang penting. Mana dia punya o-ring dia ni?
Salah ni. Kalau dalam ni. Sekali lagi kita tak barang. Hati-hati sana. Satu. Dah masuk dah. Oh dah. Nak tengok okey cukup. Abang. You know, actually kalau macam ni dia masuk. Ya, tapi this master cylinder.
Dekat kita lah.
Lagi tangan aku yang kena sebelah-sebelah lah. Oh, nasib baik tak putus. Explain di. Kau buat explain. Baru buka je.
Buka.
Yelah. Susah.
Pakai susah. Susah. Nak dengar kau ni. Keketatan. Besi.
Kau baca-baca sampai kau dah? Tarik je. Abang satu dah.
Okey, nak.
Dah.
Dah. Tu. Tadi 1958 kan?
Dekat. Bila hantar bila?
10 orang. Ya, ATIIQ pun hilang kan? ATIIQ nak datang kan? Mana ATIIQ tak ada prosedur je. Lepas tu pilih balik je tu. Cik, dah keluar.
Oh, dah.
Finally.
Where is the spring? Spring ni kita measure.
Meja lagi. Itu dah tak ada dah.
Dah, kita pergi sana.
Oh.
sana. Okey. Dah. Ngam.
Masih. Apa ada? Macam mana?
1/3.
Jangan ke mana pun.
Betul. Tak. Kau kena align pin tu. Betul. Biar spring bawah. Biarlah spring bawah.
Okey, mau makan.
Yen.
Kau cucuk.
kan?
InsyaAllah sterik. Seorang duk tekan untuk dia. Bagi dia ni. Bagi dia masuk skru ni dalam.
Nanti kau nak ni.
Ada kosong. Aku tak nampak tu.
Masuk ni.
Masuk dalam skru.
Bila tu last kali ke?
Tak tu. Kau nak ikat tu pasang ni tu. Tak masuk. Salah. Kalau tak masuk, salah.
Tak masuk. Tekan lah. Jalan je.
Tak masuk, keluarkan balik.
Yang sakit tangan juga kena buat ni.
Nampak teknik.
Dah.
ATIIQ tu.
Semak lah jari ni.
Okay, ngam.
Mana original?
Ni mana klik Asal you? Apa? Dah.
Settle.
Assalamualaikum warahmatullahi wabarakatuh. My name is Lutfil Hadi bin Muhammad Fauzan. Today I want to talk about the first question in discussion lab 2. Question is based on your finding, what is the effect of the push rod and length on the brake? The answer is our inspection involves checking the push rod length. Though the specific finding isn't detailed, we can deduce the effect based on the procedure, which mandate adjusting the push rod length by turning the end of the push rod. The point is, if the push rod is too long, exceeding the standard 9.65 mm to 9.9 mm range, it could prevent the piston inside the master cylinder from fully returning to its rest position.
Greetings and good day everyone. I'm Sarvess Ganesan, B132310208. I will be explaining to you about brake fluid. But, right, pay attention. This is the bit that stops you from having a very fast, fiery crash. What is this stuff? First, it's not brake oil. It's brake fluid. It's not a lubricant, it's a messenger. It's a force in a bottle. You see, when you stamp on the middle pedal to avoid a sheep, you are pushing this fluid down a tiny pipe. Because the fluid cannot be squashed, it instantly slams your brake pads onto the discs, and this is pure hydraulics. What goes wrong and why you crash? Well, this is where it gets serious. The fluid has two enemies. One, heat. Stopping a 2-ton SUV from 100 kilometers an hour crash creates biblical amounts of heat. If that heat makes your fluid boil, it turns to gas, air, and unlike the fluid, air loves to be squashed. The result, you hit the brakes, the pedal goes squish right to the floor and nothing. You just sail on, silently sailing towards your doom. The second enemy is water. This is a sneaky one. Most brake fluid is hygroscopic, which is a $10 word for it's a sponge. It sucks moisture out of the air, and what happens when you add water, you lower the boiling point. The result, your high performance fluid has now the boiling point of a cup of tea, which means it boils instantly the first time you brake hard. Then you crash and die. This is why you must change it every 2 years. Not changing it is for the clinically insane. The types of brake fluids. The normal fluids, the .3, .4 and .5.1. This is what 99% of all cars have. It's clear, it's amber, it's normal. This one soaks up water. .4 is just a better, hotter version of a .3. It's for cars, not tractors. The weird fluid, .5. This one is purple. It is made of silicon and it does not mix with water. It's for Harley Davidson riders and classic car owners who are afraid of rust. It is not for your car. Now, the mixing rules, the really important bit. never ever mix the families. If you put purple .5 stuff into your normal .4 system, you don't get superfluid. You get goo, a thick, lumpy, catastrophic porridge that will clog everything. It's a bill for a new brake system, and then you'll crash. Secondly, don't be a cheapskate. If your car's cap says .4, do not put .3. You are deliberately lowering the boiling point. That is like buying a guard dog and feeding it sleeping pills. It's not good. How will you know what your car needs? Honestly, a child could do this. Look at the cap on the brake fluid pot under the bonnet. It is written on it in enormous letters. It says use only .4. So use .4, right? That's it. Don't get it wrong. Thank you.
Hi, my name is Mohd ADLI bin AZMI. I will answer for the discussion question 3 about the hydraulic tube connection. So, the question is, name the hydraulic tube that are connected to the master cylinder and where all the tubes are connected. For the answer is, the hydraulic tube connected to the master cylinder are known as a brake line. The master cylinder is responsible for the converting the non-hydraulic pressure into the hydraulic pressure. The brake line carry the hydraulic pressure to the sleeve cylinder. In the typical vehicle, this means the line runs from the master cylinder port to the front brake caliper and the rear wheel cylinder or caliper, where the cylinder sleeve are located.
Okay, for the conclusion, this experiment successfully achieved its objective of inspecting, removing, and refitting the master cylinder. We observe wear and failure indicators such as a pitting on the inner cylinder surface and hardening and cracking of the O-rings, which are typically causes of fluid leaks. By following the structure produced, including carefully removal, detailed inspection, and final reassembly and bleeding, we confirm that the critical link between proper component condition and overall vehicle brake handling. That's all from us. Thank you.